positive displacement pump, they will focus on volume of liquid that pump can be that device that pump can transfer it at certain specific time. So for piston pump, so we have the cross-sectional area of piston, and then we could multiply with the length, with the stroke, and then we multiply with the RPM, so we could get the flow rate. So for gear pump and the lobe pump, so the difficulties that we have is we need to calculate the volume that created by that pump. So that is a little bit challenge, because the design of gear and design of lobe is actually not symmetrical, not an easy shape. So means that might be we could calculate a little bit more on the geometrical part of the gear pump before we could get the volume of that gear of the lobe, or the volume of the lobe of that pump. Okay, let's say we look for problem number 1. So this is for the gear pump. There is an internal external gear pump. Assume it is a module gear with this number Z equal 13. The diameter of the addendum circle is 75 millimeters. The distance between center points is 65 millimeters. Gear width 35 millimeters. Volumetric efficiency is 90%, and the rotational speed is 1500 RPM, and we need to calculate the flow rate of the pump. So I think in your design subject, you know how to draw gear. Awak ada belajar kan? Gear. Saya tengok sini ada kan? So jadi maknanya perkataan addendum, dedendum ni common kan? Dah pernah dengar kan? Lupa dah ke?
Lupa dah tu, addendum.
Okay. Saya tengok dalam syllabus rakan-rakan saya yang mengajar design ke apa ada. Dia ada slide addendum, dedendum. Okay. Tapi idea dia mudah je. Seperti yang saya katakan, gear positive displacement pump, dia kita kena tahu berapa isi padu air yang dipindahkan setiap kali berlaku pusingan, satu pusingan atau sebagainya. Jadi di dalam gear pump, kesukarannya itu ialah kerana kita tak boleh nak mengira isi padu tu semudah piston pump. Piston pump dia silinder je. Awak tahu cross-sectional area, darab panjang awak boleh dapat, awak darabkan dia berapa kali dia bergerak dalam masa 1 minit. So awak boleh dapat flow rate. So tapi untuk dalam gear pump dengan lobe pump ni, kita kena lebih kepada memahami design itu sendiri. Okay. So saya ringkaskan kerana kita tak fokus kepada design. Okay, for this question, so assume that our gear is a module gear. So I think there are a few types of gear. So the most simple one is the module gear. The module gear ni ialah why it's called a module gear, because it design the gear based on one specific numbers, and that numbers is called a module. So dia buat ratio. Okay, so for example addendum, a ratio of module. So dedendum, certain numbers times with the module numbers and so on and so forth. So let's say ini yang paling mudah. Saya cuma beri contoh supaya trigger awak how to calculate the flow rate of the gear pump. Because for gear pump and lobe pump, there are no specific equation. You cannot simply use the idea of Q equal AV to calculate the flow rate and so on, because you need to determine the volume transferred by the gear pump by yourself, because the gear is different in terms of teeth number, the width and so on and so forth. Okay. So let's say this is the design of the gear. You know that we have addendum, we have dedendum here, and then dedendum means the level from the pitch here to the bottom here, and for sure to make sure that our gear is not stuck, so we need to have a clearance here. So and then so this is just a revision. You know that this is the whole depth, for example. So and then we have the addendum at the top here, and at the bottom here is the dedendum. And here this is the addendum for this gear, and this is the dedendum for the top gear. Okay. So and then you could read this from this from the notes that I upload in my website. So first, this is the idea how the gear pump works. So first, when the flow go through this space, so the vacuum created here as this unmeshed oil enters from the reservoir. So and then when the gear is rotated like this one, so the oil is carried around, housing in chambers formed between teeth, housing and side plate, and then at here, forced out of pressure port as teeth goes back into mesh, and then the oil will push to the outlet. So ini yang sebenarnya yang berlaku di dalam gear pump. Okay, so this is the estimation. Okay, they estimate the volume in gear pump. So the most common dimension that you can get from the gear pump is, first you could get the value of C. C means the distance from this center point to this center point, because we have two exits here. So two gears, so this is the distance between two center points. And you could calculate the D here. So D here is actually the distance, the diameter from the top of the addendum here to this point. Okay, so we call it D. So or gear external diameter. Or we could calculate the value of small d here, means the distance from this point to this point. So if we could, means center from this point to this point, so we could get a small d according to this diagram. So to the capital D here, we need to calculate from here to the diameter from here to the next one, not to the center point. So okay, so for a capital D, so it's actually the addendum circle. So this is the capital D, and here the addendum circle here is actually the small d. Okay, so I hope you could understand the diagram. And then we have the W here. So and then to make sure that we could calculate the volume isipadu, so we must make sure we have the width. GW is gear width, not gravity time width. Okay, so it is a gear width, the symbol for this one. Okay, then so this is the two common equation to estimate the volume of the gear pump, because as I said, we have difficulties to calculate, to measure exactly the volume of the gear pump. So we need to compare with the experimental works, but at least we have equation to estimate. So there are two common equations to estimate the volume width. So first is this one, and the second is this one. So for the first equation, so the calculation is quite common, because we are calculating the cross-sectional area, because we have a gear. You could imagine that if we have gear here and we have a teeth, this one. So what we need to do is we calculate the area of this area. So what we need to do is we calculate pi r square or pi d square over 4, means the cross-sectional, the area of the circle. So we deduct the bigger circle area with the smaller circle area, mean the addendum circle area deduct by the addendum circle area. That's why the equation is pi over 4 d square minus small d square here. So and then we need to multiply with the gear width, okay, to get the volume. So please understand that this equation is actually to calculate the volume, not the flow rate yet. Okay, or you could use the second equation, so which is the d square pi over 2 d square minus c square times gear width. So in this equation we use c2. C square means the distance between two center point. So when you use this equation, you must use pi over Okay, this is not pi over 4 anymore because it used another ideas to calculate that one. So, but to simplify our lecture here, so please, it is okay for you to remember these two equations. But be careful if you want to use the distance between two center points. So you need to use pi over 2. Okay, and then let's try to calculate with both equation. For example, from the question, we know that the addendum circle diameter is 7.5 millimeters. And then number of teeth is 13. So, and then we know that the center distance from the two gears is equal to 65 millimeters. Okay, so this is the point data that we get from the question. So then we try to calculate what is the dedendum diameter. So because it is a module gear, so we need to calculate what is the number of module. So module is the pitch circle diameter divided by the number of teeth. So this is the fixed equation for if you design a gear. So we have 65 over 13, so we get 5 millimeters. So this 5 millimeters is actually for module gear. So the module gear is equal to the addendum value. So means that the addendum is actually 5 millimeters. So because we are using module gear, so the addendum is 5 millimeters. So and then the dedendum, so this is also the fixed equation for the module gear. So this is the information for you. So designer will create addendum. Designer will create dedendum with the ratio of 1.157 time module time m. So we get if m is 5, so we get 5.785 millimeters. So and then the total depth means the addition of this one, addendum and dedendum. So we add them both. So we get 10.785 millimeters. So and then to get the diameter of the dedendum circle, so we could calculate like this one. So and then we could get the diameter is 53.43 millimeters. So now this is the diameter for the small d. So and then we have this one. Okay, so we have the volume is pi over 4, d square, the addendum circle, and this is the dedendum circle, and then we multiply with the gear width. So we could get the volume, and then to get the volume flow rate here, so we need to multiply with the RPM. So and then we are now using 1500 rotation per minute. So we divide into 60. So and then we could get this term 1,904,000 millimeter cube per second. And then to simplify this one, we could change into 1.904 liter per second because this is a millimeter cube, is quite small. So and then for this calculation, so if you use unit of millimeters to calculate the volume, so you will get millimeters per second because we divide with 60 here as your flow rate. So it is okay, means that it is okay for you not to convert into meter and so on, because you will get a small number that might be could lead you to make a mistake. Okay, so if the volumetric is 90%, so means that the actual flow rate for that gear is actually 1.7136 liter per second. So this is the volume flow rate for that gear pump. Then if we use the second equation, so please remember we need to multiply with pi over 2. So we could substitute the value because the value of A, the value of between two center point is given in the question, 65 millimeters. So we substitute, we multiply with the RPM, so we get this value, and it is equal to 1.924 liter per second. If the volumetric efficiency 90%, so the actual is 1.7316 liter per second. If you see the value, so it is not different so much. It is 1.71 and this is 1.73 liter per second. It's quite acceptable value for to estimate the flow rate for the gear pump. So this is the gear pump. So and then we go for the lobe pump. So for example,
Betul.
yeah.
Yang formula untuk addendum tadi tu memang darab dengan memang dia punya addendum darab dengan 1.157
Yang 1.157 darab M tu, darab apa addendum tu, itu adalah ratio untuk modul pump sahaja. M modul pump untuk modul gear. Awak cuba search type of gear, nanti dia ada banyak. Dia ada metric gear, ada, tak salah saya lah, dia ada beberapa jenis gear. Kalau modul gear dia pakai 1.157. Ada gear yang pakai 1.25 saya rasa. Okay, ini very specific equation untuk kita design gear yang kita namakan dia adalah module gear. Okay, boleh ke?
Okay. Kemudian yang total depth tu dia tambah
tambah ni lah addendum, campur addendum ni awak boleh tengok berdasarkan gambar rajah ni kan. Gambar rajah ni kalau awak tengok addendum ni sampai dekat bawah sini, betul kan? Jadi kat sini ada clearance. Dia mesti ada clearance. Kalau tak dia touching nanti gear awak boleh stuck. Okay.
Okay lah.
Itu sebab saya cakap pengiraan volume ni lebih kepada geometrical punya calculation bagi orang design gear lah. Tetapi untuk orang dalam fluid mechanics ni kita tak beratkan kepada theoretical cara nak buat gear semua sekali, kerana ini bukan syllabus kita, betul kan? Kita fokus kepada untuk, tapi kalau melibatkan gear pump, maknanya awak kena berusaha dapatkan isi padu tu dulu, baru awak boleh kira flow rate. Okay, boleh dapat Okay, so maknanya dalam gear pump, lobe pump dan sebagainya ni selalunya jarang orang boleh buat apa nama tu Bernoulli equation ke velocity triangle ke, dia tak berlaku dalam gear pump. Okay, tapi dalam aliran dalam pipe yang dialirkan oleh gear pump, awak masih lagi boleh menggunakan Bernoulli equation. Tetapi dalam gear pump itself tu, maknanya bendali yang ada di dalam gear sewaktu gear berpusing, lobe berpusing tu, kita kata dia memerlukan pengiraan daripada sudut yang lain. Okey, boleh ke? Okey, kita sambung dengan soalan kedua. Soalan kedua, we are focusing on lobe pump here. So let's say we have a lobe pump running at 300 RPM. It's pumping soybean oil through a 3 cm diameter pipe. The pump is driven by a motor that is using 285 watts. Assuming an overall pump and motor efficiency is 65%, what is the pumping rate if the suction and discharge pressure are -35 and 660 kilopascal respectively? So here we are going to calculate the pumping rate here. So and then it trigger us, it give ideas of pressure for inlet and outlet. So equation that have flow rate, so it's actually power is equal to rho g q and h. So and then because from this situation we don't have a pump head, so we could use the idea of pressure, because pressure for inlet and outlet is clearly mentioned in this situation. So what we need to do is we just bring the H here. So we write our equation for power as rho GH times Q. So means that the rho GH here is actually a delta P, means the pressure difference between outlet and inlet. And normally, okay, for sure, inshallah, it's the situation is like this. At inlet point, the pressure must be lower, or it must successfully create a suction condition. So means the pressure must lower the atmospheric pressure. That's why it gives you minus value here, and the outlet pressure must be greater than atmospheric pressure, because the energy, the higher pressure energy will convert into kinetic, then it can transfer water to the higher level. So if we substitute we calculate the delta P here, so we write as 150 minus 35, so we have positive 195. So and then we need to multiply with 1000 because the unit here is in kilopascal. So and then we let Q as the unknown parameter. So we have the 195,000 Q here. So and then we could calculate the flow rate, because so this is the power. I'm sorry, so this is the power according to what we have here. So mean this is the power output. Okay, so this is the power output, and then we have the efficiency. So the idea is power out divided by power in. So power out is 195,000 Q, and then power in is actually power given by the electrical port. Or so in here it stated as that motor is using 285 watts, so means that is the power supply by the electrical point. So we write as 285 here. So the efficiency is 0.65 because it is 65%. So then we could calculate the Q here. It is equal to 0.95 liter per second. So if you could see here, so especially in our calculation for Hardy-Cross method, normally people will use the unit of liter per second, because liter per second is quite easy to understand. Because if you give 0.00095 meter cube per second, it is difficult a little bit for us to imagine the amount. If liter, you could amount that the PET botol, awak ada botol air tu kan, so awak boleh agak tu lebih kurang 1 liter. Okay, so jadi maknanya kalau awak cakap 0.95 liter per second, awak boleh imagine dalam satu saat berapa banyak air yang dialirkan berbanding dengan orang cakap 0.005 meter padu. Okay. So this is the calculation for the lobe pump. So and then we go for this one. A two-lobe rotary positive displacement pump move 0.60 centimeter cube of motor oil in each lobe volume. For every 90 degree of rotation of the shaft, one lobe volume is pumped. If the rotation rate is 550 RPM, calculate the volume flow rate. So normally in lobes rotary pump, they will give you the volume of one lobe. So one lobe means the volume of water carries at this area. So if it is not given, so mean you need to use the geometrical value. So you need to open the drawing, you need to calculate what is the value for one lobes. So and then for every 90 degree of rotation of the shaft, one lobe volume is pumped. First, you need to understand the statement of this one, because in some question of lobe pumps, they will not given this statement. So I just put this statement because I just want you to understand the mechanism of the lobe pump. So here, so this is the vertical lobe, and at this situation, another lobe is in horizontal position. So and then when this up here, so we assume that liquid at this area will flow out. So and then when this so when this lobe is straight like this, vertical like this one, so this lobe is actually will horizontal like this one. So mean that the rhythm of the lobe is actually in 90 degree. So that's why it says that in every 90 degree of rotation, one lobe volume is pumped. So and then the RPM is 550 RPM. Okay, first you need to understand the mechanism of the lobe pump, and please you make sure that you could create this statement for every how many degree, so how many volume is pumped. And then to calculate the volume flow rate for lobe pump, first you need to calculate the velocity of close. So velocity of close means the total velocity of water, of liquid, that being transferred for one cycle. So because we have every 90 degree, a certain value, a certain volume of water being transferred. So for one rotational, mean for 360 degrees, so we have 4 times. So we have 4 times 0.6. So we have 2.4 centimeter cube. Why we use centimeter cube? Because in the question they will give in centimeter cube unit. So we just use the same unit, is okay. So and then the equation, an official equation for calculate the volume flow rate for lobe pump is like this one. So we have Q V close times rotation times lobe speed. So here, okay, V close means the total volume for one rotation. So we already calculated as 2.4 divided by one rotation times 550 RPM. So we get it is around 1,320 centimeter cube per minute. So why we use per minute? Because we use 550 RPM. So we maintain the unit of minutes here. So we need to represent a unit of minutes in our final answer. So this is the idea of dimensional analysis. You previously in fluid mechanics 1, we learned about the dimension, times, and so on and so forth. We learn about units. So this is the importance of that idea. So to know what is the final unit in our calculation, you must base on what unit that you use in your operation. So make sure that you not mix with minute and second, centimeter cube, millimeter cube, and so on. You must make sure that you use all the same units, and then that unit must appear in the final answer. Okay, so because I don't divide this into 60, so the unit of minutes will appear as the final answer. Okay, so and then we go. So this is the last question actually for the lobe pump. So let's say we have a 3-lobe pump, a 3 lobes rotary positive displacement. Let's say I just use the same question. Let's say the volume for one lobe is 0.6 centimeter cube. So and then okay, the RPM is also the same. So I just write this statement. So I hope you could write your own statement, because normally the statement of for every certain degree how many volume is being transferred is not written. So here that I want you to share here is we have 3 lobes. So this is 3 lobes. So let's say we have a 3. So people might be a little bit confused, because the shape here is similar like this one. Okay, so if we see the 2 lobes, so the shape is, one is vertical and one is horizontal. It's quite perpendicular to each other, but this one, the idea is the same. And some students, they will times with 3, because they only see a 3 compartment here. But I want to make some discussion here. Okay, so let's say if this lobe move from right to left like this one, so means that first the lobe here is in horizontal. So and then when it moved there, it rotate counterclockwise like this one. So these lobes will fall down like this one. Okay, so and then what happened to the left hand side lobes? So this lobe will change its location to the horizontal one. Okay, can you imagine that? It become horizontal like this one. Okay, so from this motion, you will find that this is actually the So you will have this term and this term. So this will be 180 divided by 3. So you will have 60 degree. That's why you must know that for every 60 degree of rotation, one lobe volume is pump. Okay, so I hope you need to study the mechanism of the lobe pump here. So because we know the 60 degree here, so and then to solve this one, we calculate the total volume for one rotation. So because we have 60 degree, so we need to, for one rotation, so the total volume being transferred is 6 times 0.6. So 0.6 is given in the question, and then we have 3.6 centimeter cube. So and then to calculate the flow rate here, so we multiply with the RPM. So we have 3.6 times 550 RPM. So we get the volume is 1,980 centimeter cube per minute.